Okay, good morning. So today we're going to be doing a brief introduction of two-factor ANOVAs. So we're going to go over a simple data set and we're going to compute a two-factor ANOVA table in R. So this is relatively simple if you know what to do. It doesn't take too long to learn. Just as long as you learn the separate factors, you can be able to figure it out relatively easy. It just might take a while to get used to plugging everything in. So let's get started right now. I'm going to share my screen. All right, this is just a simple homework problem. So it's going to tell us to download a data set, and that's what we're going to do. So we downloaded a data set, and we're going to download it right now. Okay, it's downloaded. So now we're going to be looking at our R. And for those of you who know, I'm just using RStudio. RStudio is, in my opinion, the best. You can do this in Excel, but I preferentially prefer R. R is a lot better. So what we're going to do here, we downloaded the dataset and we're going to import it. So our dataset is right here. One way to import it, you can import it through multiple different places. The way I prefer to import things is right through here in the files. So you can go through your files, you can see, okay, like for example, okay, right here, I'm going to import this. And then you can see our data right here. Our data is relatively simple. We have a two-factor ANOVA, and we have two factors that we're going to have to change two factors in R. And we also have a response variable. The response variable is relatively easy to figure it out. That's obviously here, that's absorption, because sorption is numerical, and as you can see here, it makes sense that it's going to be the response variable. So that's what we're going to pick as a response variable. So we're going to push import here. We have our code here, everything looks great. So we're going to import it. All right, so you can see the data up again here as well. So that's our data right there. So what we're going to start doing, the first thing we need to do is we need to rename our data set, and we need to turn the concentration and ratio columns into factors. So whenever you start off doing these ANOVA tables, especially two-factor, you got to turn things into factors unless they are already. But most of the time, if you download a data set and it's an Excel file, you're going to have to turn it into factors. So let's do that. Let's turn our two factors into factors. So what we can do here is we're going to do this code I did earlier. We have example.csv, which is what I named this data set. We have concentration, right? That is our first factor. As you can see, it's up right here. So what we're going to do is we're going to do example. You do a $sign. So let's do it right now. So what you're going to do, you're going to do example, right? .csv, then $sign, and then concentration, right? This concentration is the one we want to turn into a factor. So we're going to do here, and then we're going to do the same thing again. We're going to do as.factor, right? So this is going to turn our variable into a factor. So we're just going to do that real quick right here. So as.factor, then we do example, right? .csv. Right, and then $sign again, concentration. So this is saying, okay, we have our name of our column, which is a concentration column. So right here, we named this column right here to make sure that it knows we're working with this right here. And then in the as.factor function, we're turning this whole column to a factor. So we're going to do that right now. And now we need to do the ratio. So the ratio also has to be turned into a factor. So let's do that. So we're going to do the exact same code we did above, but we're going to do it for ratio, because ratio is going to be our next factor. Ratio as.factor, right? And then we can do rename the data set again, and then $sign and ratio. So this will turn our ratio into a factor. And now there's a number of things you can do to bring up the actual ANOVA table. There's one way to do it is you can do an AOV and do summary AOV. We'll bring out a full two-factor ANOVA table. Or you can do, for instance, you can do a linear model, and then you can do an ANOVA function of that. And there's multiple other functions you can download in the packages folder over here. But for the sake of time and also for this one, we're going to use just AOV. AOV is going to both use a linear model and also it's going to keep our factors in place. So that's what we're going to do right here. So let's do it right now. So we have AOV, right? AOV is going to be our initial step to figuring out this ANOVA table. So when you do an ANOVA table, the response variable always goes first in those parentheses. So our response variable, as we can see, is called sorption. So sorption is right here, right? Then we can do this little symbol, a tilde, and then we're going to do our two response variables. And it doesn't really matter what order you put them in, but for this sake, we're just going to do concentration and ratio. So concentration, make sure you spell it right. Otherwise, you're going to have a lot of issues because it's not going to compute it correctly. It'll give you an error symbol. So then we're going to do multiply, which is basically saying that these have interaction, right? Whenever you have this multiplied right here, right there, and also, of course, right here, this is saying, okay, this is interacting with each other. We know for a fact it is. If this were a blocking factor to ANOVA, which we'll get to later, then we would have an addition symbol, which is going to say we don't care about these interactions, but we do care about these interactions. So we're going to use a multiply symbol. And it's going to be ratio, right? And then we're going to do comma, then we're going to do data equals, and then we're going to example 1. Sorry, I spelled example. Example 1.csv, right? Because this is our data. So this is basically what I explained. This is our response variable. Then our two factors, which we turn into factors, right? And then this right here, this lovely thing, is basically saying, where are we pulling our data from? We're pulling our data from this thing up here that we just like put into place, right? We imported. So always make sure when you're working in R, when you do data equals your data set, you need to get everything right in there. And usually it'll pull it up as you start typing it out. But make sure your data is the data. And if you renamed the data as well, make sure you have the original data set that's untouched, right? So one thing you could also check for is if you stack the data as well, you need to name the stacked data ANOVA. And we'll get into stacking our data as well when we're working on ANOVAs. So the first thing we should do is we just press enter, right? Now, I don't really like this ANOVA table it gives us right now, right? It gives us very base, like not very like computed out. So what you can do to make the ANOVA table with the AOV function a lot better, a lot cleaner, and you actually have an ANOVA table with the interactions is you're going to do summary, right? The summary function is going to make everything very beautiful. So I'm going to go ahead and copy this because I don't feel like typing it out again, right? So we're going to do control paste. And now this is going to be our summary of our full ANOVA table, right? So this is our summary. This pulls everything out. As you can see, concentration and ratio. It gives us our degrees of freedom of these factors, right? It gives us our sum squared. It gives us our mean squared. It gives us our F statistic, which is our t-value, our test statistic, and it gives us our p-value. So as you can see, this p-value is extremely small, and this p-value is also very small. So we can see that all these things are going to add up to our total residuals, right? But right here we have our ANOVA table. So this is a very simple way to do an ANOVA table. We have this code right here, and this right here, of course, is our interactions. So if you ever do a problem and ask for interactions, you're going to want to look at this, right? This is our degrees of freedom for the interactions. This will be our sum squared for the interactions, our mean squared, our F value, our P value, and so on and so forth. So this is a very simple way to get our ANOVA table. And so what we need to do right now is we need to discuss if the additive model is going to be plausible. So I'm going to share my screen. I'm going to share my R again, my R Studio. Okay, so looking at this, right, there's a number of different ways we can actually tell if the additive model is plausible. My personal way that I like to do, but this isn't always the case because on a test or an exam, it might not always give you the same values, right? So my preferable way I do this is, as you can see in my tutorial notes, I have that if the additive model, if the test statistic is greater than a critical value, right? That means the additive model is not plausible. And also, if the P is less than the alpha, the additive model is not plausible. So I preferentially like P is less than alpha, right? Because I don't have to compute my critical value. But basically what you're going to say here is you're going to say, wow, okay, so look at my P. My P value is right here, right, for the interaction. It's a really small number. It's not as small as one up here, but it is like 6.24 times 10 to the negative fifth, right? That's really small. But what we know, what we can understand from this is that our alpha, which by default, always by default is 0.05 or 95%, right? So 0.05 is going to be a lot bigger than this really small number. So therefore we can tell that the additive model is not going to be plausible. And because the additive model is not going to be plausible, we can say that we are going to be rejecting the null hypothesis, right? Which is HO. So one other thing, and this is very, very important because in the test they might ask you this, if you're computing this in R and you want to understand about the significance of the function, right? The interactions. So in this, we can see, well, our interactions, these are all the values we computed, right? And for a two-step ANOVA or two-factor ANOVA, this is very, very important, right? So we can look at this and we can say, okay, well, if I'm looking at this in the additive model, we can see that we obviously said the additive model is not plausible, right? If the additive model is not plausible, the interactions are significant, right? So we can say in this function we did, the additive model, right, is not plausible, which means the interactions are significant. So it can go vice versa as well. You can say, well, if the additive model is plausible, then the individual values are going to be significant, right? So if we determined, this isn't the case for this one, but if we determined that this is not plausible, the additive model is not plausible, then you would say, okay, the individual factors are significant, right? But for this case, in the ANOVA table we just computed, with the data set we just downloaded, we're going to have to say, well, this is very, very simple. We can understand this, that our interaction values are significant, right? Because our P is less than our alpha, or if we want to compute our critical value, our test statistic, which in this case is 8.3, is bigger than our critical value. So in this case, we're going to have to say that our additive model is not plausible and the interaction values are significant. So when you're going over these ANOVA values and ANOVA tables, just keep in mind that these things are very important, all right? So what I'll do is I'll put these notes in the description and you'll be able to look at them and just be able to determine how to get through homework. All right, thank you very much, bye.